In this video, we will answer the question, a politician wants to figure out their chances of winning an upcoming election. A survey of 3,600 people was conducted. In the survey, 52% of those sampled said they would vote for the politician. Is he likely to win the election? Attach a 95% confidence interval to your answer. Now this is an example where we have the sample, but we do not have the box. So if 1 represents a vote for the politician and 0 a vote against the politician, we do not know how many 1s and how many 0s are in the box being the population. We do know the number of draws, however. The number of draws is the sample size, which in this case is 3,600. So here we do not have an expected value. Instead, we will use the percentage of 1s in the sample. In place of the expected value. We have a formula for the SE for percent. That's the number, let me get this right, that's the SD of the box over the square root of the number of draws times 100%. We know the number of draws is 3,600, so this is okay. The 100 is fine. But what about the SD of the box? To calculate the standard deviation of the box, we need to know how many 1s and how many 0s there are. But we don't know how many 1s and how many 0s there are. So instead, we will estimate the SD of the box using the bootstrap method, which means instead of figuring out the 1s and 0s in the box, because we can't do that, we don't know how many there are, we'll use the 1s and 0s in the sample. So the SD of the box is approximately 1 minus 0, because 1 is the big number in the box and 0 is the small number in the box, times the chance of drawing a 1. Again, we don't know that because we don't know the box, but we'll say it's about the same as if it was the chances of drawing a 1 in the sample. In the sample, that was 52%. Make sure you have that in decimal format, which means the chance of drawing a 0 is 48% or 0.48. So let's plug that into the calculator. So 0.52 times 0.48, take the square root, and that's 0.4996. Now we're ready to calculate the SE for percent. Again, this is an estimate because we don't know the percentage of 1s and 0s in this box. Plugging this into the calculator and multiply by 100, and we get 0.833%. So less than 1% is the SE for percent. So we've substituted the expected value with the percentage of ones in the box, 52%, and we estimated the SE for percentage was a little less than 1%. So the question is, will he win the election? And we want to attach a 95% confidence interval to justify our answer. Now if we go to the normal curve table and we look for the number closest to 95, it's right here, 95.45% is associated with z equals 2. Since it's associated with z equals 2, that means we want to go plus or minus 2 standard errors from our expected value. So plus or minus 2 standard errors from 52%. So we take the 0.833 multiply by 2. And get 1.67%. That means the 95% confidence interval is 52% plus or minus 1.67%. Let's get the actual range here. So we take 52 minus 1.67 and get 50.33%. And we take 52 plus 1.67 and get 53.67%. So what we can conclude here is we can be about 95% confident that the percentage of voters that will vote for the politician is between 50.33% and 53.67%. So based on this information, it does look like he will win the election. However, keep in mind there's still a chance that he could lose because we are about 95% confident that he will fall somewhere within this range. If you have any questions about this video or questions about confidence intervals, please let me know in the questions and answers discussion board.